Hi everyone, welcome to tutorial 59 of our Introductory Python for Image Processing tutorial series. Until now, we looked at various ways of manipulating our images, or we can call it image processing. But once you process the image, you would like to manipulate the data. And for that, we're going to use a popular library for data analysis called Pandas. Whether you want to do regular statistical analysis or whether you want to get your data ready for machine learning, Pandas is almost the industry standard. So I'm going to divide this into 5 or 6 tutorials, starting with obviously very basics, and then slowly getting to know how to sort data or group data and eventually plotting. Let's jump in. In the first tutorial, we're going to look at loading the data. So Pandas library, to install it, all you need to do is pip install pandas, pip install pandas, and hopefully things should work fine. And once pandas is installed, you have to import it like usual, right? I mean, pandas. So this is how you import the library, and then you're all set to go. Now, let's go through this line by line. Again, I've composed this so we don't waste our time, typing the code. So let's actually focus this line by line. So starting with the first line. It's customary to import. I just said, okay, go ahead and import pandas, but it's very customary to import pandas as PD because it's very easy for us to type just PD dot rather than pandas dot. That's pretty much it. Just like how you would do numpy as NP, okay? So now once you import that, let me actually run these lines to show you. In fact, let's run this line and the next line to show you how easy it is to, let's go ahead and run this one line one more time. Up. It helps if we select the right lines. Okay, so let me show you how easy it is to actually come up with a plot that looks like this. So all we're doing is importing a CSV file that has a bunch of data, and we are actually plotting a column called area. So this is how easy it is, or this is how easy Pandas makes it for us to handle the data and also to get it ready for plotting or machine learning. Now let's actually dig a bit deeper. Okay, so let's clear the screen so everything looks clean. And start over again. And let's also clear the variables that we have stored until now. Let me scroll down. Okay, so the data is handled as a data frame in Pandas, meaning when you define a data frame, think of data frame as a Excel sheet. It's not fair to compare Pandas with Excel because Pandas can do a lot more and it's a lot more powerful. But if you are coming from Excel background, this probably helps. Okay, so think of it as Excel where you have rows and columns. And then, or in fact, think of it as an Excel table where you have rows and columns and each column has a title. Okay, so that's what a data frame actually is. And you can define an empty data frame once you import your pandas, right? I mean, let's go ahead and run this line. We imported the pandas, and then you can define a data frame, and typically the variable that gets assigned to this is df, again short form for data frame, but it can be anything. I mean, it's customary to use df, and the way you define a data frame is basically, okay, your pandas.dataframe, that's it, pandas.dataframe, and when you do this, it's going to define an empty data frame. If you look up here, it says df is the name, and the type of it is the type of this variable is a data frame, and it has 0 columns and 0 rows. This is how you define a data frame. Now, this is an empty data frame. If you already have some data, you can go ahead and add it. In this example, I defined my data as 10 to 160, so I have like 4 of these and 3 rows and 4 columns. So let's go ahead and run this, and so far this data is just a list of size 4, right? So this is a list of lists, and each entry here has like 3 values. So far we just defined a list. Now let's convert that into a pandas data frame. So if you already have an existing list, to create a pandas data frame, all you got to do is just what we have done so far, which is pd.dataframe. And within the brackets, instead of leaving it empty, obviously we're going to say, okay, we want to fill it with data, which is a list that we have here. Let's actually do that and not worry about the rest of this because I'd like to talk about a couple of a couple of features here. So let's go ahead and only create a data frame using our data here. Okay, so let's go ahead and run that line. And if you look at our data frame, now our data frame has a size of 4 by 3. Now let's open it and have a quick look at what we have here. So this is exactly what we have defined here: 10, 200, 60, 12, 155, 45, and so on. So this is again how easy it is for you to define a data frame. Now, if you look at this column, it says index. Anytime you define a data frame, you must have index. And index is a unique identifier for that specific row. So if I say, okay, my index is 1, and look at the column number 1, you know exactly which value I'm talking about. So the index must be a unique identifier, and you can define your own index. If you don't define your index, then it's going to give it an automatic index value. Same with the column names. So let's change that now. Okay, so instead of defining our data frame as just data, in addition to that, I'm going to provide a custom index. So instead of going from 0, 1, 2, 3, I want the index to be 1, 2, 3, 4. Okay, and I want to label my columns. If I slide this, let me create a bit of more room here. My column labels are going to be area, intensity, and orientation. Okay, I'm just simulating some data. So here, the first one is area, the second one is 200 is my intensity values, and 60 degrees is my orientation. So when we run this, now you should see our data frame still has 4 by 3. Now you see the index starts from 1, 1, 2, 3, 4, and my column names are appropriately assigned here. So this is how you define a data frame, by using your own data and your own index and your own columns. Now, most of the time, you are not going to type in all the values. Most of the time, you'll probably start off with a CSV file or text file or wherever the data is located. HTML, it doesn't matter. Pandas can read multiple file formats. So that's what we are going to look at right now. So let me erase the variables again, and let's clear the screen and start from scratch one more time. Okay, in this example, I'm going to assign my data frame to pandas pd.read CSV. So if you actually type pd dot, you can just do read CSV, you can do read Excel, it has multiple options. Go ahead and explore it on your own time. But in this case, I'm using read CSV, which is comma separated, and my input file, or the file I'm trying to read, is located inside a folder called data, and it's called manual versus auto.csv. So let's go ahead and import this. Let's run both of these lines. Okay, there you go. And my data frame now, you can open this in Spider. In other IDEs, you have other ways of opening these, but let's open this in Spider. So the first column, as you can see, is index, and it automatically assigned this an index starting from 0, 1, 2, 3, like it did the last time. And the next column, it's called unnamed, because that column in my CSV file has no label. So it just labeled it as unnamed 0. If I have 5 columns that have no labels, it's going to be labeling them unnamed 0, unnamed 1, unnamed 2, and so on. So we can assign a label later on, but for now, let's just leave it. And the second one here is image, and then the image numbers are going from 1, 2, 3, 4, 5, 6, 7, 8, all the way to 100. Now, as you can imagine, this image column can also be an index. So if you don't want the default index, if you don't want the default index to be 0, 1, 2, 3, but if you already have a unique identifier, then you can make that your index, and we'll see that in a minute. And the next 4 or 5 columns contain some data, and let me explain what I have. So I have a column called manual and another column called manual 2. The manual column, again, this data represents someone counting number of cells or number of nuclei in a given image. And I have 20 images or 25 images per set. As you can see, I have set number 1, and then set number 2, set number 3, and set number 4. I have 4 different sets, and in each set I have 25 images, total 100 images. And some person went through this and individually counted the number of nuclei and then entered the value here. So in image number 1, 92. And a different person did exactly the same thing, and they ended up with a value of 93. Okay, this is just my way of looking at is automated, more repeatable, reproducible, more accurate compared to manual way. But the problem here is the second person kind of gave up after the first 3 images and said, I have better things to do. I don't want to count this anymore. I don't blame that person because we have to automate these tasks. It's not a good use of your time to sit down and count every nuclei. Machines can do a well, equally good, if not a better job in a much more efficient way. Okay, and the next 3 columns here are automated ways. Okay, I set different thresholds in my automated nuclei counting, and these are the values I ended up with. And for automated way, I do not have any blanks because every image got analyzed. This is the advantage of machines. Now, in the manual column, I have some NaN stands for not a number, means it's missing. There is no value there in my CSV file. So some of these NaN numbers, we need to take care of them. Otherwise, we don't know how to work with them in these columns, right? Same problem with Excel. If you look at the mean number of cells, how does it treat these non-numbers? So we'll have a look at all of this, but I want to make sure I spend some time explaining this data set. So now let's go back. Okay, so now that we imported this file, let's go through a few basic commands that are available as part of Pandas. First of all, df or data frame, I assigned it a value of df, right, or a variable name of df. If you just type df.info and keep an eye on the right hand side here, it actually gives you a quick information about this data frame. And you can see here, these are all the column names: unnamed, image, manual, manual 2, and these are a non-null count. So here we have 100 cells that are not null, meaning we have value there. In the manual column, we have 94, and 6 of them are NaNs, meaning null. And we already saw that, okay, we have only 3 values for manual 2 because this person gave up some after the first 3 images. So we only have 3 non-null, and in the others we have 100 non-null. This gives a very quick overview. And the data type is also very important, especially if you work with time series data and you want to do some forecasting, some predictions, then it can be important, you know, for you to define your time or convert your time from, for example, a text or an object to the date time format, right? So I'm not going to cover that in today's tutorial, but just to give you an idea what's important, why this can be very helpful, okay? And if you just type df.shape, it's going to tell you the shape of this data frame. So we have 100 rows and 7 columns. That's what df.shape is going to give us, and printdf is going to print the entire data frame. Obviously, it's going to truncate it at some point. It's giving me like the first few and then the last few. That's pretty much it. There you go, much better view there. And if you want to only look at the top 5, let's not provide a value there. If you type df.head and print, it's only going to give you the top 5. Similarly, df.tail is going to give you only the bottom 5, the full information. Now, if you want the bottom 10, you can just type a value in there and then it gives you the bottom 10. So these are some quick tools to get a better understanding of your data. Now let's go down and look at a couple more. So df.index, remember, our index, again, let me open the data frame. Our index is going from 0 to 99, right? So we have 100 data points, so it's going from 0 to 99. So we have 100 of this. So df.index is just giving you, okay, what is your index? Where does it start? Where does it stop? And what is the step size? That is your index. But now we said, okay, we don't want that default index. We want our image column. Again, I shouldn't have closed, but this image column as our index because it already has a unique identifier and it means more to us than just some random numbers. To make that your index, you just need to do df.set_index and then give whatever the column name in quotations there. Okay, so when we run this, and if you open this data frame, and now you can see that my image is the index, there is no more index column anymore. Okay. So this is how you can reassign index, and if you want to get a quick idea of all the column names, just type df.columns, okay? And it outputs it as a list. For example, if you just want to say my columns equals to, okay, df.columns, and if you run this, then if you look at your columns, this is a list of all the column names. Now you can kind of use this for example, to define features in your machine learning. Okay, what features do you have? Okay, just get the column names and this could be your features, right? So it can be very useful to get a quick look at your columns. And now let's actually look at unique. Again, let me go back to our data frame. What do we have in our data frame? If you look at this unnamed column, this unnamed is nothing but my sets. I have 4 sets, right? Set number 1, set 2, set 3, and set 4. And in each set, I have about 25 images. So if you take a column and then just type dot unique, it's going to report all the unique values. This can be very important to see. For example, you segmented your image, okay, into 5 different regions. And after segmentation, it assigns some pixel values. Those could be floating point numbers between 0 to 1, or this could be values 0, 1, 2, 3, 4, or they could be values 0, 122, 244, an 8-bit type of values. But if you really want to know, okay, what is the range? How many values do I have? Just go ahead and select the column. In this case, the way we select is df, which is our data frame. And in the square brackets, just type the title. This is a weird title. We'll change that in a minute. But go ahead and type it and dot unique. And if you do that, let's print it out on the screen. You see, it returns a list saying set 1, set 2, set 3, and set 4. So this gives me a good information about what type of data do I have in a given column. If you have like 100 unique values, then you'll end up with 100 of those, right? I mean, if we just look at print, let's go ahead and do this one more time, except in this case, let's actually do manual column. And let's look at it, and these are all the unique values. And the manual column is, again, this column where a person actually measured or counted, I should say, the number of nuclei, and these are all the unique values. So it's not like I have only 5 or 6, I have a whole bunch of these. Okay, so and now let's go ahead and rename. If this name of your column is bothering you, you can change it to something that makes sense to you. So you can use that later on in your processing. So the way to rename a column is, okay, I want to, by the way, you can assign this to a new data frame. Okay, so far we just looked at the same data frame. Now if I say df1, a new data frame is nothing but my old data frame where I rename my column unnamed 0 into image set. Okay, so if I run this, up here you should see a new data frame. And in this data frame, this column name is going to be image set. Now, I recommend not to do that, meaning saving a data frame as a new data frame unless there is a strong reason to do so, because if you're doing subsetting and that you're doing some analysis, then that makes sense. But in this case, we're just cleaning up the data. So let's assign the cleaned up data to the same data frame. Okay, that's what that df stands for. And now you can rename this. Now, if you want to rename multiple columns, look at this. This is just a dictionary. All you got to do is just put a comma and then add the next value and key pairs. Okay, so that's how you rename your columns. Okay, now missing data, I would like to save it for the next tutorial. But if you just go ahead and print df manual, you'll see. Again, let's get to missing data. Sorry about that, but let's wait for that. A couple of things I want to show. df.dtypes is very important, which is the data types. We kind of had a quick snapshot of this earlier when we looked at our df.info, where it actually provided that information. But again, data types is very important, because if you want, for example, in this case, my manual and manual 2 are floating point 64, but then these 3 happen to be integer. And now if I want to do some math using these numbers, I need to be aware of what the data types are. I can change the data types if I want. And finally, I had this part commented out just to say that, okay, you can rename multiple columns. I just mentioned that over there, but here is an example where I renamed multiple columns. But let's end this tutorial by talking about the describe functionality. And I do this almost all the time whenever I import a new CSV file or create a new data frame. You'll see why, because when I run this, it gives you a very good snapshot of, okay, for each of these columns, how many do we have? We have 94 entries under manual. And under auto, we have 100. We know that, right? I mean, we have 100 data points. Here only 94, and here you have only 3. The mean, which, of these values is this, the standard deviation, the minimum, the 25th percentile, 50th percentile, and all that. So this, and the maximum is 120, which means in one of the images, someone counted, I mean, this person counted 120 nuclei. On average, you have about 100 nuclei here and 91 here. Right away, you can tell that, okay, manual here and manual there is a discrepancy, but this represents only 3 images, so it doesn't mean anything. But here you can actually compare in a real way. So this gives a very nice snapshot of your data set, and as it correctly says, it describes your data frame. I hope you found this tutorial to be useful, and in the next one, let's actually build on top of this. And now in the next one, let's do a bit more data handling, and after that, sorting and grouping and so on. So let's meet again in the next tutorial. Until then, please do not forget to subscribe to this channel so you're notified whenever we upload a new useful video for you. Thank you.